Welcome to AI Frontiers. Today we explore language at the frontier, insights from 109 computational linguistics papers from May 2025. This podcast examines groundbreaking research at the intersection of language and artificial intelligence. In today's presentation, we'll journey through the current research landscape in language technology, examining key themes including evaluation methods, multimodal approaches, reasoning capabilities, and efficiency improvements. We'll spotlight breakthrough findings that challenge our understanding of language models, highlight methodological innovations driving the field forward, and explore the implications these developments have for the future of language technology. Let's begin with an overview of computational linguistics. The field has evolved dramatically from its early rule-based systems to statistical methods and now to neural approaches. The most recent evolution has come through large language models like BERT, GPT, Claude, and Gemini. Computational linguistics spans diverse areas, including parsing, translation, generation, and dialogue systems. The field is increasingly multimodal, integrating text with vision, audio, and other modalities. Alongside technical advances, there's a growing focus on ethical considerations, fairness, and responsible deployment of these powerful technologies. The first major research theme we observe is evaluation and benchmarking of language models. Researchers are developing increasingly targeted benchmarks to test specific capabilities rather than general performance. For example, Shen and colleagues revealed that vision language models struggle significantly with visual negation, showing these models often fail to properly interpret negative statements about images. Wang and team introduced a framework specifically designed for evaluating chatbots across multiple languages. The field is moving beyond simple accuracy metrics to probe reasoning abilities, understanding of linguistic phenomena, and potential biases. There's also growing concern about the gap between synthetic and human-authored evaluation data, with evidence suggesting synthetic benchmarks may not fully capture the challenges of real-world language use. The second prominent research theme focuses on multimodal understanding, bridging language with other modalities such as vision and audio. Zhang and colleagues examined bias in vision language models through a question-answering framework, revealing how these biases manifest across different input types. Liu's team developed methods to ensure spatial coherence in multimodal synthesis, addressing the challenge of generating content that respects physical constraints. This research recognizes that human communication is inherently multimodal. We don't just use words, but also gestures, expressions, and visual cues. Different modalities provide complementary information that, when integrated properly, leads to more comprehensive understanding. This integration is crucial for creating AI systems that can interact naturally with humans in real-world settings. The third significant research theme explores reasoning and knowledge in language models. We're witnessing a shift from viewing these models as mere text generators to sophisticated reasoning systems capable of complex problem solving. Kim and colleagues explored the trade-offs involved when models reason in different languages, finding important implications for global deployment. Patel's team demonstrated methods to teach models how to combine atomic reasoning skills to tackle more complex, previously unseen reasoning tasks. There's growing focus on how knowledge is represented within these models, how facts are stored, retrieved, and applied. Despite impressive advances, addressing hallucination and ensuring factual reliability remains a critical challenge, particularly for applications in high-stakes domains like healthcare, finance, and legal settings. Our fourth research theme combines efficiency and multilingual capabilities, both crucial for making language technology accessible worldwide. Sharma and colleagues demonstrated optimization techniques that allow sophisticated language models to run effectively on mobile devices with limited computational resources. Garcia's team proposed efficient methods to expand language model capabilities to support new languages without requiring complete retraining. Research on cross-lingual transfer is enabling knowledge sharing between languages, allowing models to leverage information learned in one language to improve performance in others. There's increasing emphasis on reducing computational costs and environmental impact of language technologies, with researchers developing more efficient architectures, training methods, and deployment strategies that maintain performance while requiring fewer resources. Let's examine some breakthrough findings from across these papers. First, research on vision language models revealed a surprising U-shaped scaling trend in negation understanding. As models grew larger, their ability to handle negation initially degraded before improving at the largest scales. Second, large language models demonstrated the ability to recall content across languages, even retrieving information when prompted in a different language than it was originally encountered, suggesting these models develop abstract, language-independent knowledge representations. Third, researchers identified a critical trade-off between reasoning in non-English languages and answer accuracy, with models forced to reason in languages other than English, producing less accurate results. Fourth, self-critique mechanisms reduced explanation unfaithfulness by 18.79% without requiring external supervision, demonstrating models' capacity for self-improvement. Finally, studies consistently found that synthetic benchmarks underestimate the challenges presented by human-authored content, raising important questions about evaluation methodologies. Innovation in research methodologies is driving progress across computational linguistics. Contrastive evaluation approaches compare model performance on closely related tasks to isolate specific capabilities. Cross-lingual probing techniques assess how knowledge transfers between languages, revealing both strengths and limitations in multilingual models. Self-improvement frameworks enable models to critique and iteratively refine their own outputs without human intervention. Controlled generation using knowledge graphs helps ensure factual consistency and coherence in model outputs. Multimodal evaluation across text, images, and structured data provides more comprehensive assessment of model capabilities. These methodological innovations are crucial for advancing our understanding of language models and developing more capable, reliable systems. Let's examine one particularly significant study in depth. Chen and colleagues investigated negation understanding in vision language models in their paper, When Seeing is Not Believing, Vision Language Models Fail at Negation. They evaluated 20 vision language models across 7 model families using a specialized benchmark with paired positive and negative visual questions. Their findings revealed significant performance drops of 15 to 40% when models handled negated questions compared to their affirmative counterparts. Most surprisingly, they discovered an unexpected U-shaped scaling trend related to model size. Medium-sized models actually performed worse on negation than smaller models, with performance only improving again at the largest scales. These findings have serious implications for safety-critical applications requiring accurate visual reasoning, such as medical imaging or autonomous vehicles, where misunderstanding negation could lead to dangerous outcomes. Another groundbreaking study by Rodriguez and colleagues, Beyond Translation, Cross-Lingual Memorization in Large Language Models, investigated how language models store and retrieve information across languages. The researchers created a data set of aligned excerpts from 20 books in 10 languages and tested models' ability to recall information when prompted in different languages. They found that advanced models could identify authors and titles with 69% accuracy, even when the information was presented in a different language than originally encountered. This provides compelling evidence for language-independent knowledge representation in these models. Performance varied significantly by language pair and linguistic distance, with closer language families showing better cross-lingual recall. These findings have important implications for developing multilingual information access and retrieval systems that can serve users regardless of their preferred language. Patel and colleagues made significant advances in model self-improvement with their paper SRNLE, Self-Refining Natural Language Explanations Through Iterative Critique. They developed a framework enabling models to critique and improve their own explanations without external supervision. Testing across 3 datasets and 4 state-of-the-art language models. They demonstrated that this approach reduced unfaithfulness rates from 54.81% to 36.02%, an absolute reduction of 18.79%. This research demonstrates large language models' metacognitive capabilities for self-improvement, suggesting they can reflect on and enhance their own outputs. The approach offers a potential pathway to more trustworthy AI explanations in high-stakes domains like healthcare and legal settings, where understanding a model's reasoning process is crucial for building trust and ensuring appropriate use. Looking toward the future of computational linguistics, several key directions are emerging. We anticipate development of more nuanced evaluation methods that test specific capabilities rather than general performance. Advanced techniques for cross-lingual and cross-modal knowledge transfer will help create more versatile systems that work across languages and input types. Continued research on model self-improvement and metacognition promises to enhance reliability without requiring extensive human supervision. Greater focus on efficiency and accessibility will make these technologies available across languages and devices, including in resource-constrained environments. Finally, the development of ethical frameworks for responsible development and deployment will be crucial as these technologies become increasingly integrated into critical systems and everyday life. A brief note on how this presentation was created. The content was synthesized using GPT and Anthropic's Claude, Chapter 3.7, Chapter Sonnet, Chapter 25.0219. Text-to-speech synthesis was performed using OpenAI's TTS technology, while visual elements were generated using Google's image generation capabilities. The content was reviewed by human experts for accuracy and clarity. Despite careful review, some oversights may exist. All references to original research papers are provided in the accompanying materials. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.